So, Assalamualaikum dan selamat malam, salam sejahtera ya. Salam sejahtera ya. So, jadi untuk malam ni, seperti yang kita janjikan, kita akan tengok tutorial 3 ya. Tutorial 3 Momentums and Impulse. Jadi kita nak mulakan kelas kita pada malam ini. Jadi saya harap kamu boleh nampak skrin saya, tutorial 3, Momentum and Impulse. Alright. So, jadi kita pergi dulu kepada soalan yang pertama, yang untuk objective question. Question number 1. Question number 1, momentum is defined as product of force, rate, change momentum, product mass, velocity, and product force and time. So as you know, the momentum P is equal to mass time velocity. So meaning the momentum is product mass and velocity. So if look at the answer number A, number B, number C, and number D. So the answer is C, product of mass and velocity. This is number 1. Right. Next question. Go to the number 2. Right. Next question. Question number 2. One-dimensional impulse force X and objects on figure 1. So where is figure 1? This is a figure 1 graph, force versus time T. Based on the graph force versus time T above, what is represents impulse? Right? For the graph force versus T, the area under the graph here is equal to impulse, right? For graph force versus T. So now represent impulse, the answer is T. Okay, kelas. Maksudnya kalau kita ada graph force versus time T, kalau kamu cari area under the graph, so dia bersama dengan impulse. Right? So next, we go to the next question. Question number 2. Right? Number 2 finish. Question number 3. Okay. Question number 3. According to the principle of conservation of linear momentum, okay, kinetic energy is not conserved in the presence of external force. Linear momentums of system remain constant. In absence of external force, the linear momentum of system remain constant and momentum is not conserved. Linear momentum is the definition. You can total momentum before is equal to total momentum after. So this is principle of conservation of linear momentum. Jumlah momentum sebelum sama dengan jumlah momentum selepas. Tetapi untuk kes ini boleh berlaku hanya tanpa kehadiran external force. Maksudnya sistem tu dia dalam isolated system. So if you look at the answer here, answer number C, in absence of external force, right? Because this is for the conservation of linear momentum. This is total momentum before is equal to total momentum after or final. And this is for isolated system, we know external force X on the system. This is number 3. Okay, next, continue to number 4. Which statements is false about inelastic collision? So we have 2 types of collision. Right? The first is a inelastic, and the second type if we have a elastic collision. Right? So the difference, if you differentiate between inelastic collision and elastic collision is first, if you look at the momentum before or total momentum after final, right? F conserve. But if you look at the kinetic energy, so right here kinetic energy is KE, kinetic energy initial, total kinetic energy final or after. For the inelastic collision, pelanggaran tidak kenyal, momentum conserve, meaning jumlah momentum sebelum sama dengan jumlah momentum selepas. Tapi kalau kinetic energy, dia tidak conserve. Maksudnya kat sini kinetic energy initial is greater than kinetic energy after. Okay, maksudnya kat sini tenaga kinetik sebelum pelanggaran lebih besar daripada selepas pelanggaran. Ataupun kita boleh katakan kinetic energy initial is not equal to total kinetic energy after. Ataupun kita boleh katakan total kinetic energy kalau yang elastic conserve. Okay, dia kalau yang inelastic sebaliknya. So kat sini dia kata false statement. Meaning kalau kita nak cari, kalau kamu tengok dekat dekat jawapan yang dibekalkan kat situ, number A tu dia kata apa? Total momentum is conserve, total kinetic energy is conserve. Maksudnya kat sini the answer is B, because ini adalah kalau dia melibatkan inelastic, kinetic energy not conserve. Tapi ini untuk kalau elastic collision. Alright, so this is number 4. Continue to number 5. Right? This question number 5. The main difference which distinguishes inelastic collision from elastic is that, so if you look at the answer given and answer number A, number B, number A momentum and number C is look at the kinetic energy, right? So this is inelastic collision. So inelastic, if you look at the momentum, momentum before is equal to momentum after. This is conserve. But for the kinetic energy initial is not equal to total kinetic energy after. So if you look at the answer A, B, C, D for inelastic, so meaning the difference between elastic and elastic is a kinetic energy for inelastic not conserve. So the answer is a D. So if you look at the answer number C, kinetic energy conserve, this is referred to the elastic, right? Elastic collision, right? And both of elastic and inelastic momentum is a conserve. So that's why the answer is a D. Okay, class, finish for objective question. Continue the subjective question. right? So number 1 for subjective question. Okay, number 1 ask you what is impulse, right? What is impulse, and show the relation between impulse and force. So look at the definition. So first is a symbol of impulse is J, and the impulse is a product of force and time T, right? So this is how you can define, how you can apa kita nak jelaskan itu impulse. So kita boleh kaitkan dengan force and time T. Atau pertama dia adalah F. Jadi kalau kamu cek kat sini, dia punya C itu, F itu adalah berkadar. Okay? C is equal to FT. Okay. Go to the next question. Okay, next question number 1B is a calculation. Okay, so a ball with a mass 400 grams is moving horizontal with a speed 13 meter per second. Okay, you have the ball, let's say, and moving horizontal with a speed 30 meter per second, right? And hit the wall, so in front of the wall, we have the wall, and the ball hit the wall, and after that rebounds. Okay, dia melantu balik pada arah pertentangan pada kelajuan 18 meter per second. And the process ini kata kat sini within in 0.1 second. So proses yang dia pergi langgar dinding ni berlaku dalam T 0.1 second, masa yang cepat sini, proses pelanggaran di antara bola tu dengan wall di sini. So question asks you, what is the impulse? So to calculate the impulse here, you can start with the equation impulse J is equal to Ft. Also, impulse is equal to the change of momentum. So for the question here, you can use a relation between impulse and change of momentum. So if I write here, J is equal to delta P. Delta P here is a change of momentum. Change of momentum, momentum final minus momentum initial, right? So momentum P is equal to mass time V. So this is equation for momentum. So the impulse here equation is a momentum final minus momentum initial. Momentum final, this is the collision between ball and wall is the ball moving to opposite direction, to the initial direction, 30 per second, and the mass of the ball is 400 grams. So meaning here momentum is the mv final, okay, velocity, final velocity minus mass time u, initial velocity. Okay. So mass, because we have the symbol here, it's not staying constant, we have for unit here is gram, so convert to the kilogram is 10 power of minus 3, and time, okay, we have u v minus u, right? So now here v here is v final here is 18, but the direction to the left, so you must use a negative 18, and minus u initial velocity is 30, right? You can find the value of impulse here, So the impulse, you can use the calculator, and 400 and 400 times 10 power of minus 3 times 13 minus 3. So the final answer is, and so I'm gonna give it. So I have yeah, this is equal to minus, because it's minus 1 to 12.4. Okay, unit is a Newton second. So you have the minus here. So the minus here, this is the direction of the impulse. Okay, the direction of the impulse to the from the wall to the ball after rebounds, the direction to the left. So this is a then that's why this is a, you have a negative sign here, but the magnitude impulse is a 12.4, right? So meaning if you get the answer given by the equation is 12.4, this is referred to the magnitude, or you can use a negative 12.4, right? Okay, so this is number 1B. So we continue to the next question, right? All right, yeah. Ada lag ah? That's okay kan? Sekarang ni okay kan? Sangat okay. Okay, saya rasa tak ada masalah. Kita boleh teruskan lagi ya. Okay, we go to the next question. Question number 2. Yeah. Question number 2. Okay. Net force 8 Newton acts on an 18 kilogram body of for the 1 minute, right? So this is the net force on the 8 Newton. 8 Newton. So meaning you have the force 8 Newton. 8 newtons acts on the mass 18 kilogram. The process here is T in 1 minute, right? 1 minute. So that means the impulse to the force. So the question asks you to calculate the impulse. So the impulse is equal to force time T. So the force is 8 Newton. 8 Newton. And the time here is 1 minute. But use the second as I unit. So we have 1 minute, we have 60 seconds. So meaning the force here is 8 times 60. We have 480 unit impulse is Newton second. Okay, class. So this is the straightforward. Okay. The next, calculate initial velocity. Initial velocity of body. So we have a equation J is equal to Ft. J is equal to Ft. Also impulse J is equal to delta P. Okay, now the impulse J is a change of momentum, or momentum final, say final minus momentum initial So this is mv minus mu. So if you look at the question here, ask you to calculate the initial velocity. So what is the u here? And mass is constant, right? So here, but the impulse, you already calculate. This is answer number, sorry, this is answer. The first is impulse, we have a 480, right? 480, and you have a mass. So mass is a 18, so 18 kilogram, and the v final, because the final velocity given is a 60, right? 60, and so we have a minus initial velocity is a u. So now you can calculate the value of the u here, right? So you can use the calculator. Right, so the u is 480. So saya akan boleh kira sendiri ya nanti empat yang ni. So, sepatutnya dapatlah jawapan sini, dia akan bagi 33.33 meter per second. Ini pun saya rasa straightforward. Okay, soalan ni tak ada just penggunaan perkaitan rumus ini ya. Impulse C, you can relate to the force and T time T, and the impulse is a change of momentum. Okay. Okay. Oh, sorry. Alright. Saya okay, tak ada yang like apa semua. Okay. Okay, so continue to the, sorry, question number, the next question number 3, right? Question number 3. Okay. This number 3. Okay, question number 3. An object mass 0.25 kilogram move at a velocity of 24 meter per second. So yeah, you have still have object, and with a mass 0.25 kilogram and moving with a velocity 24 meter per second along the straight line. After it has collided with another object, okay, setelah dia langgar dengan satu objek yang lain setelah di depan dia, right? Okay, mungkin arah tak bagi tahu, cuma dia kata selepas dia berlanggar tu, it's moves a velocity 40 meter per second in opposite direction. So now here is a collision between the two objects. Okay, the first objects with a mass 0.25 kilogram, and the second objects, this is unknown objects. Yeah, the question not mention the mass and the velocity, but after the collision between the two objects here, velocity of the object 0.25 kilogram moving okay, after collision, right? After collision, the object moving with the opposite direction, velocity 40 meter per second. So meaning here, for the object 0.25 kilogram, we have change of momentum, right? And the question number A asks you the impulse. So meaning the impulse J, you can relate to the change of momentum. Change of momentum here is equal to final momentum mv minus initial momentum, right? So now to calculate the impulse, so you can use the J is equal to, so we have a mass, okay, M V minus U, right? So V minus U here. So now we have the mass is a 0.25 kilogram, right? And V here, and the V here is a final velocity, 40 meter per second, but direction to the left. So you must use here negative 40, right? Minus initial velocity is a 24. So now you can use the calculator here to find the value of the impulse J, negative 40 minus negative 24 times 0.25 kilograms. So the final answer is a 16, and sorry, negative 16, right? Negative 16 kilogram meter per second. The negative because of the direction of the impulse of the on the ball 0.25 kilogram J to the left. This is negative. Okay, 16 kilogram meter per second. Okay, class. Number A. We continue the number B, and then number B here is the average force. Okay, average force apply on the object if impulsive force has x for 2t is equal to 4 millisecond. So meaning here, when the two object here, okay, pelanggaran di antara dua objek, objek 2.0.25 kilogram and another object ni, proses pelanggaran itu memakan masa selama 4 ms here is a millisecond. So millisecond here is referred to the time t, right? Time t. Milli is time 10 power of minus 3. So the question asks you to calculate the force. So what is the force applied when the proses ataupun the object 0.5 kilogram collide with another objects. So you can use the equation impulse is equal to J is equal to force time T. So now because of J impulse is come from the answer number 1, okay, negative 16. You might use a negative because here you can the answer, the question asks you to calculate the force. The force is a vector quantity, meaning you must have a direction of the force, right? So the force F and the process time taken for the process is 4 milli is 4 times 10 power of 3. So you can find the final answer F is equal to negative 16 divided by 4 exponent 3. This is equal to the answer, the final answer here is right, negative 4,000, right? 4,000 Newton, right? This is answer for number 3B, right? Okay. Okay, so we continue to question number 4, right? Question number 4. Okay, kelas, saya harap tak ada okay, tak boleh nampak skrin, tak ada masalah ya. Okay. Okay, continue to question number 4. Right? Question number 4. A ball of mass 2 kilogram, moving with a velocity 3 meter per second along the smooth horizontal track. Oh, you have an object 2 kilogram, moving with a velocity 3 meter per second, right? And collide with a stationary ball. So we have a stationary ball in front of the object 2 kilogram. This is mass stationary ball is 4 kilogram, right? And this is stationary, meaning so initial velocity is equal to 0, right? And if the balls stuck together after the collision, so meaning this is before collision, and after collision the two objects stick together, okay, dia melekat and bergerak dengan satu halaju v kat sini ya. And so this is inelastic collision, right? So inelastic collision. So now the question asks you to calculate the velocity after collision. So what is the value of the velocity of the collision here, right? So now you can use the conservation of the linear momentum. Total momentum before is equal to total momentum after, right? Okay. So now total momentum before is here, right? And this is Pi, and this is total momentum after, right? So before we have a momentum for the mass 2 kilogram time velocity, because momentum P is equal to mass times v, so 2 kilogram times v is 2 times 3, right? And plus, because the 4 kilogram object is a stationary, meaning 0 momentum, and after collision the objects stick together, so we have a mass 2 kilogram plus 4 kilogram, meaning 2 plus 4 and time v, right? So this is times, yeah, sorry, 2 plus 4, right? So now you can find the value of the velocity here, right? So the value of the velocity, if you use the calculator or you can use the calculations, the v here is equal to 1 meter per second, right? So if you this is the answer given by the question. So 1 meter per second. Okay. So continue to the question number 2. Total kinetic energy before and after collision. So now, so kinetic energy before collision, so we have a half m v square for the object 2 kilogram, and plus the second object, because second object is stationary, meaning we don't have a kinetic energy for mass 4 kilogram, right? And after collision, the kinetic energy here is half, because stick together, meaning you must plus 2 kilogram plus 4 kilogram, this is a 6 kilogram, time v is velocity, this is answer question number 1 meter per second. So now if you use the equation here. So we have the value of the kinetic energy before. Okay, before is half, mass is 2, and the velocity is 3, right? Is equal to half times 6 is times 6. 6 times 1 is 6, right? So here, if you look at the equation here, so if you cancel 2 here, so we have a, sorry, this is square, right? This is square. So meaning here, if you calculate here, this is a 9, and this is a 3, right? 9, 3. So this is not equal to before and after. So meaning this is a inelastic collision here, right? Inelastic collision. Why inelastic? Because total kinetic energy before is not is equal to total kinetic energy after, right? This is question number 4. Okay, class, continue to the next question. We go to question number 5, right? Number 5. Okay. So question number 5. Oh, sorry. Right. Question number 5. 0.2 kilogram model car moving with to the right with the speed 0.24 meter per second is struck from behind by the 0.42 kilogram model truck moving along the same line with the velocity 0.52 meter per second. Right? They stick together, and after collision, stick together after collision and move with the common velocity v. So meaning here we have a inelastic collision, right? So two objects collide, and after collision, so we have the object stick together, okay, dia melekat dan bergerak dengan satu halaju halaju v, right? So ini dia punya cerita dia ya. Okay. So this is 0.2 kilogram and velocity is 0.24, and the second mass is 0.42, right? And kilogram, and the velocity is 0.52 meter per second. This is unit meter per second. Okay, calculate velocity v. So you can use the equation or start with the total momentum before is equal to total momentum after, right? Sorry, after F. So before is this is before. Okay, total momentum before is come from object 0.2 kilogram and object 0.42 kilogram, right? So now momentum before here is 0.2 times 0.24, right? Okay, plus 0.42 times 0.52. It's before collision, and after collision we have a stick together, meaning we have a mass m1, we have a 0.2 plus 0.42 times v. So now you can use the calculator to calculate the value of the t. So if you use the calculator, the value here is 0.2, right? 0.2 times, so we collect MA, right? So 0.43 plus 0.43 meter per second. Okay, so this is answer given by the question 0.43. Okay. Right. Okay. Okay, continue to the question number 6. Now, question number 6. So, number 6. Three blocks. A, B. This is actually the A, right? A, block B, and block C. This is M, and this is 2M, and this is 3M. Are placed in horizontal smooth plane as shown in figure 2. So you can look at the figure 2. We have the two objects A, B, and C. And block A with a speed 80 meter per second. So we have 80 meter per second for object A. And collide and stick with block B. So meaning object A collide with the object B, right? Object B, A, and both object collide and stick block C. Oh, maksudnya first block A dia langgar dengan block B, and the next dia bergabung, melekat, terusnya berlanggar dengan block C, and dia melekat juga. So kalau kita tengok kat sini dia merujuk kepada inelastic collision. So the question asks you to calculate the velocity V. Okay, it moves with the velocity V. Calculate velocity V. So now here, to find the solution for question number 6, sorry. Alright. Alright. Here. Okay, so you start with the first situation is the first part between object A and B. So because it's inelastic collision, right? Collide and stick together with the block B. So we have M A U A plus, this is first part, right? For A and B, and B U B. And after collision between A and B, the object stick together. So meaning we have a MA plus MB, and we have a V before collide block C. So now you can find the V here first. Okay, the first part. So use the value for MA here is M, right? UA is time 18, right? And MB here is equal to 2M, right? This is 2M. And UB, because stationary, so we have a 0 here, right? MA is M, MB is equal to 2M. So because we have M left and right, so we can cancel item M here. So you can find the value of the V here. So the V here is the speed of the block A and B. Stick together with the velocity V. So V here is equal to, so you can use the calculator here. So this is 1, this is 2. So the V here is equal to 6, right? 6 meter per second. So meaning here, if I draw the diagram here, A and B is now A and B, right? Now A and B stick together, object A and object B with the velocity 6 meter per second. And after that, collide with the object C. So now, what is the final velocity if the object AB collide with the block C and stick together. So meaning here we have a mass AB, UAB initial before collision, AB plus we have collide with the vector block B, but block B is stationary, right? So okay, write the mass C time UC, and after collision the object here is stick together, so meaning we have a inelastic collision, meaning mass AB plus mass C time V, and the question asks you what is the value of the V here, right? And so you can use the value for MAB is a mass A and B, so meaning we have a M plus 2M, we have a 3M. And UAB is a 6 meter per second. This is the first answer. The first before A and B collide with the block C. So combination block A and B have a 6 meter per second velocity or initial velocity 6. Okay, mass of C is a 3m, but you see is stationary, meaning it's equal to 0. MAB is mass A and B, meaning M plus 2M. So we have a 3 here. And the MC is a 3M. So 3M. So you can use the equation here to find the value of the V. So now if you calculate the value of the V here, so V here, the final answer, if you use the calculator here, this is V is equal to 3 meter per second. So if you look at the answer given by the question is also the correct answer, 3 meter per second. Right? This is number 6. Okay, class, we continue to the question number 7. Right? Question number 7. Okay. Question number 7. Object sorry. Object A and B mass 1.5. So this is 1.5 kilogram. So the second object B is a 2 kilogram. Right, and respective okay, on horizontal, you can see the figure 3 here. Okay, small figure 3, B at the rest. So meaning we are initial velocity U is equal to 0 for B because stationary. And A move with the constant speed 4 meter per second. So now the speed of the A is 4 meter per second. While the B moves while B moves with constant speed toward the vertical wall. Constant speed. Or after collision, selepas pelanggaran A dengan B, B itu bergerak ke arah ini, this is wall, vertical wall, and A move opposite direction. So meaning after collision, A or right here is a VA, final velocity for A after collision is a 2 meter per second, but the direction is opposite direction. So make sure you must use a negative sign here because direction is to the left. Okay, when the B strike the wall exert impulse magnitude 15 Newton second on B. So after the collision, B goes straight to the wall and the ball collide the wall and the wall give a impulse on the object B, 15 Newton second, right? So now find the speed of the B after collide with the wall. So we have korang kata situasi soalan yang amat panjang. Cuma kat sini kalau kita ringkaskan, A bergerak berlanggaran dengan B, stationary tak bergerak. Selepas pelanggaran A rebound ataupun terpelantur balik ke arah pertentangan, manakala B bergerak ke arah wall. Bila B bergerak ke arah wall, dia langgar wall, and wall itu, pelanggaran itu akan menyebabkan B itu akan mungkin terpelantung balik ke arah pertentangan, tetapi wall itu akan berikan satu impulse kepada objek B ataupun force kepada objek B. So jadi kat sini what is the speed of the, let's say we have a final velocity after rebounds, dia berlanggar dengan dinding VB here, right? So apa pelanggaran, apa nilai V kat situ, itu dia punya situasi yang mau ditanya oleh soalan. Jadi kalau kita nak bermula kat sini, first untuk cari VB kamu perlu tahu ni lah apa, because kalau saya ambil situasi di sini sekarang ni situasinya, kalau saya pindahkan sekarang ni, kita cuma ada situasi soalan terakhir dia cuma nak tahu bila B ni bergerak dengan satu halaju U, initial U lepas tu dia berlanggar dinding. Ini berlaku selepas A tu dia langgar B. Okay, A tu dia langgar B jadi dia langgar wall, lepas tu bola B tu akan dipantul balik pada arah bertentangan. Okay, opposite direction. Okay, B. So meaning here, kalau kita tengok kat sini, untuk dapatkan berapakah V ni, VB sekarang ni berapa, so, kita boleh tengok balik kaitan antara impulse J dengan momentum akhir minus momentum awal. So right here, impulse J is equal to final momentum minus initial momentum, ataupun A minus U. So ini kita nak belum maklumat untuk kita mencari. Actually B kat sini sebenarnya B di sini lah, kita nak cari B di sini. Cuma maklumat yang dibagi lagi kat sini, dia kata magnitude impulse 15 Newton. Okay, Newton second after object B collide with the vertical wall. So meaning here the J here is a 15. So now we can use the equation here, mass mv minus mu. But the question asks you to calculate the V here. V, right? What is the final V after collide with the vertical wall? So mass of the B, I think is given by 2 kilogram. Okay, this is 2 kilogram mass. Okay, this is given by the question. This is also 2 kilogram. So to calculate the V, you must know the value of the U. So here is before object B collide with the vertical wall, what is the value of the U? So to calculate the value of U, kembali kepada situasi awal, iaitu untuk cari objek B ni, kita kena guna konsep pelanggar momentum, iaitu momentum sebelum is equal to conservation momentum, right? Before and after. Sebelum kita tengok situasi ni balik, situasi pelanggaran A dengan B, dan kita dapati A dengan B ni dia tidak melekat, because according to the equation, so after collision A moves opposite direction and B moves to the straight to the direction to the vertical wall, right? Okay, alright, so here, okay, initial we have a MA times UA plus MB mass B UB. Okay, and after collision, so this is elastic collision, maksudnya dia tidak melekat selepas pelanggaran. So we have a V final after collision VA plus MBVB. So ini dia punya nilai. So kalau kita gantikan kat sini, kalau kita gantikan nilai MA sini adalah 1.5 and U here is U here is 4, mass B is 2 kilogram, and the UB here is UB is horizontal. So what is the B? B at rest. So meaning here we have a 0 here, and MA is 1.5, right? VA here VA here move after collision, A move opposite direction 2 meter per second. So here we have a -2 because of direction of the A after collision to the opposite direction. And the mass B here 2 kilogram, and you can find the value of the VB. So VB here is referred to the UB before second part or second situation, right? So this is UB after collide with the object or ball, object A. So now here you can find the value of the VB. Eh? So you can use the calculator here. So use the calculator, VB, this is equal to, right? Okay, that VB is equal to, okay, 4.5. VB is 4.5 meter per second, right? So you can use the value of the VB here to the equation U here 4.5. So we have a 4.5, and now you can find the value of the V here. So you can use the calculator. V15 because mass 2 kilogram divided by 2, okay, divided by 4.5. So the final answer we have -3, right? -3 meter per second. So the answer, yes, -3. So we have sorry. Oh, sorry. Sikit sini So V is equal to -3 meter per second. Okay, negative because of direction of the ball B to the left. This is negative sign here. Okay, class. This is how you can use combination impulse, conservation of linear momentum, and to calculate the final answer, right, or the speed of the ball after collide with the vertical wall. Okay, class, we continue to the next question, number 8. So we have another 3 question, right? Okay, number 8. Okay, so what is number 8? So number 8 is no diagram. So 1.5 kilogram ball was hit initial velocity 40 meter per second and the angle 60. This is like the projectile motion. We have the ball and speed, initial speed 40 meter per second with the angle theta is 30 degree. It's horizontal line. Calculate initial momentum of the ball. Also horizontal and vertical, meaning we have this is object, the ball 1.5, and this is velocity. So the momentum, initial momentum here is equal to, so what is initial momentum? Because momentum is equal to mass time V. So the mass is equal to 1.5 kilogram, and V here, V is velocity is 40 meter per second. So you can find the value of the momentum. 40 times 1.5 is 60 kilogram meter per second. So this is initial momentum. Momentum here, P is equal to 60. 60. So now the question asks you to calculate horizontal and vertical. So now if you look at this is a y-axis and this is a x-axis. So if you relate, let's say 40 meter per second, momentum to the y-axis here, right? So here if you resolve to the y-axis, so the momentum, let's say use a py, right? Py is equal to mv, but mv here mass is mass 1.5, but V here is a Vy. So mass here is equal to 1.5, and the Vy here resolve 40 to the y-axis. So we use a 40 sine 30, right? Sine 30. And the Px is equal to mass time Vx. This is 1.5 times 40 cos 30, right? So for the y, we have this is a 4 sine 30 is a half times 40 and times 1.5. Sorry, we have this is 50, sorry, this is not 30, okay, 30 kilogram meter per second. So now you look at the, okay, py 30 meter per second, and the px cos 30 times 40 times 1.5, so px is equal 51.96. So if you look at the kilogram meter per second, so this is answer for the px and this is answer for the py. Okay, tidak apalah mudah kamu boleh kira sini. Sebenarnya cuma kat sini how you can resolve momentum, or you can find the py momentum and the px momentum, or you can must resolve 40 meter per second to the vy, and is 40 meter per second resolve to the vx is 40 cos 30. Right, this is question number 8. So continue to the question number 9. So number 9 is a 2 dimension. Alright, ni agak sikit complicated. Okay, tak apa, kita tengok macam mana. Okay. Alright. Okay. Okay, question number 9. A car move with a velocity 2 meter per second. So you can see that in the figure here, the car with a 2 meter per second, and the second car had the same mass, but the second car initially at the rest. So this is equal to 0. So this is the initial U for the car A. Okay, after collision, both car move 60 and 40 from horizontal. Calculate of the collision. So you look at the diagram here, so you can see the first car and the second car collide, and the second car immediately at the rest. So meaning UB, the second car UB is equal to 0. And after collision, the car A moving to the upward with the 60 degree from the x-axis, and the second car VB moving to the 40 degree, right? So now calculate the final velocity. So what is the VB and what is the VA? Jadi sebenarnya kalau kita nak tengok berkenaan dengan 2D kat sini, first kamu kena resolve item ini kepada PX dan kepada PY. Okay, momentum untuk yang arah paksi X dan arah paksi Y. So macam mana kita nak buat yang ni? So first kalau kita ambil, kita ada PX axis dulu ya. So the first axis sama juga, kita guna konsep this is a let's say conservation momentum. Momentum before is equal to total momentum before is total momentum after, right? The first, the before is a mass of car. Okay, mass of car. Dia tak bagi kat sini. So just terus this is a MA car A time UA plus car B, UB is equal to, this is X, right? We use the X. This is for the X axis. So meaning here, VA here, you must resolve to the X. Okay, mass X. And this is VB also, we have a X. So we have a MA after collision, MA VA here is theta is a 60, cos 60. And VB here direction to the downward. So you must use a negative for the second car, VB. So we have a MB, VB resolve to the X, we have a cos 40 degree. Okay. Actually from the X-axis here, we produce, let's say this is equation 1. Right? And PY or Y-axis, momentum, okay, for the before collisions, all the item here is a horizontal line, so meaning we don't have a this is PY, sorry, this is PY, so this is the PY, yeah, so meaning before is equal to, for the Y here is equal to 0. Okay, tiada pergerakan pada arah paksi Y sebelum pelanggaran. And after collision, yes, so you have a MA, object A, the car A is a MA, resolve V to the Y axis, VA here. So we have a VA sin 60. Okay, sorry. Ada sikit kesilapan ya. Ini arah X ya. So arah X yang X axis ya. Because dua-dua ke arah ke kanan. So this is not negative, this is positive. Yang negatif tu adalah yang ke bawah Y ni ya. Sini yang negatif ya, right? Sorry, silap tadi, negatif. Untuk second car we have a MB, we have the VB, okay, sin 40, right? Let's say this is a second equation. So kamu sebenarnya dalam kes ini ya, kamu ada persamaan yang pertama kat sini. Nanti kamu kalau buat nanti buat yang lebih cantik ya, supaya teratur nampak. Ini adalah second equation. Dan kalau kamu tengok dalam persamaan sini, ada nilai yang boleh kamu ganti, ada nilai yang boleh kita cancel kiri dan kanan. Cuma kat sini ya, saya cuma nak jelaskan sahaja. Daripada persamaan ini, kamu boleh, because hanya ada 1-2 item saja yang kita tak tahu kat sini. Because mass ya, walaupun mass dia tak bagi kat sini, tetapi because mass ini kita mungkin kalau kiri kanan kita boleh cancel. Okay, katalah ini akan jadi kosong because B here is equal to 0 kereta tak bergerak. Okay, VA sini kita ada, ini kita boleh gantikan 2. Okay, lepas tu apa lagi, VA ini kita nak cari ya, ini kita nak cari VA, kita nak cari, and VB kita nak cari, and dua-dua ni adalah cos 40 dan cos 60. So meaning here kamu ada dua benda yang kamu tak tahu, unknown item kat sini, iaitu VA dan VB. Sama juga dalam sini, dua item yang kamu nak cari kat sini. Tapi kamu ada dua persamaan, first equation and second equation. So kita boleh guna kaedah simultaneous ataupun kaedah gantian. Itu matematik lah. Yang penting kat sini, kalau kamu tengok yang fiziknya, cuma macam mana kita boleh terbit dua persamaan sini. Okay, bila kita terbit dua persamaan ini, kita boleh gunakan nanti persamaan itu untuk dapatkan dia punya VA dan VB. Jadi kalau kita tengok kat sini, maksudnya seterusnya tu, ini saya tak tunjuk kat sini, saya akan boleh buatlah sini, dua persamaan sini. Kalau kita tengok dia punya ni, dia pun persamaan yang ada kat sini Okey, sekejap Okey, kamu boleh, ya, memang final answer kat sini dia bagi VA dan VB. Nanti kamu boleh, okey, sorry, kalau kita tengok kat sini, okey, oh sorry, we have the same mass ya, that's why bila the same mass itu maksudnya mass ini pun kita boleh cancel juga ni. Okay, kita boleh cancel juga sini. We have the same mass. Okay, maksudnya kat sini kalau kita katakanlah kan kalau saya buat ya. Ni saya tulis mana? Tulis kat sini. Tak ada ruang ya. Kalau saya tulis kat sini, yang kamu cuma ada nanti adalah kalau daripada persamaan pertama ni, the first equation ni, kamu akan dapat UA plus UP is equal to VA cos, first is VA is cos 60 cos 60 plus VB cos 40. Okey. Jadi kat sini kalau kita tengok, dan U pun kita boleh katakan dia bagikan U initial U is 2. Sini pun dapat 2 because U tak bergerakkan, kosong. Jadi kita ada VA cos 60 plus VB cos 40. Okey, dah makin ringkas. Ini katalah persamaan keempat sudah kita ambil kan. Okey, dan cara yang sama kalau kita nak buat, okey, kita potong dulu sini ya. Okey, untuk yang persamaan yang kita ambil persamaan yang apa? Yang kedua tu, yang Y axis tu kan. Axis awal memang kosong because tak ada kan. Tak ada pergerakan arah Y, sini kosong kan. Jadi yang Y tu dia kosong. Okey, sama juga mesh kita boleh cancel nanti because kiri kanan nanti because mesh yang sama. So kalau kita tengok yang tinggal cuma situ adalah, okey, kalau kosong terus kita ambil lah. Yang tinggal cuma, okey, sorry, 0 right? 0 is equal to VA sin 60. Sin 60, right? Minus, so we have minus VB sin 40. Sin 40. So ini katalah persamaan kelima. Jadi kamu boleh gunalah, ini dah ringkas sudah, dua persamaan ni untuk mencari dia punya nilai VA dan VB. Mana-mana satulah dalam persamaan sini. Okey, nanti kamu boleh kira sendirilah. I compare dengan jawapan yang dia bagi. Okey kelas. Okey, kalau sudah hampir 1 jam lebih dah kita ni. Okey, saya nak terus pergi kepada the final question ya. Soalan terakhir. Okey, yang ni lebih kurang sama yang tadi juga ya. Kalau kita tengok, two ball A and B, so you have a ball A and this is ball B, which velocity 25 and 15 moving in the opposite direction, right? Okay. The ball collect and each other bounce off the mass of the ball A and B to 20 and 25 gram. Calculate the final velocity of the ball B and its direction if the final velocity of ball A is 10 meter per second. Meaning here this final velocity A is a 10 centimeter per second, right? Okay, so because all the unit here is centimeter per second, so we can use a centimeter per second in the calculation. So what is the VB here? Itu yang dia nak cari kan. So sama juga kat sini, kita boleh tengok this is collision momentum before PI is equal to total momentum after, alright, final, alright. So kalau kita tengok kat sini, dia tidak, because dia ada laju masing-masing, arah pertentangan, maksudnya dia tidak, maksudnya apa, elastic collision, right? Okay, so maksudnya yang before sama juga because ini bergerak pada 2D, 2 dimension macam soalan nombor yang 9 tadi. So first kita tengok kepada momentum untuk yang X axis dulu. So kita bermula dengan objek A, so we have a MA U A plus MB U B, and for the X kita resolve kepada X. So yang ni kalau kita resolve kepada X, because dia sudah ada bagian 10 cm, so 10, but resolve to the X, this is a VX here, so we have 10 cos 35, because direction here is to the left. So to the left, so it must have a negative. And the second, we have a VB resolved to the X. So we have a positive. Okay. Mass. Okay. Sorry. Yang ni kita tak darab lagi Sorry. This is time. Right. So this is mass A. MA plus mass B time. This is a VB. Ini kita nak cari VB. Right. So this is first equation. Okay. And the second equation resolve to the momentum to the Y. So the Y here sama juga, before collision tak ada arah Y. So means is equal to 0. And the second part after collision, so resolve VA to the, this is VAY. So we have a mass A, V, A, sorry, kita terus pakai sini 10 So 10 resolve to the Y is you can use a sine 35 degree. Okay. And the second part is a VB here, direction to the downward for the VBY. So we have use negative. Mass here is a MB VB. This is for the second object B, and this is second equation. Right. So kalau kamu tengok kat sini, sama juga kat sini. Kita ada sekarang ni okay, kita boleh guna kat apa? Dua persamaan ini. Okay, untuk mencari dia punya nilai VB here. Right? Because VB ni, yang ni pun ada VB, so kita boleh samakan dua persamaan sini. Kita boleh samakan dua persamaan sini. Kalau saya beringkaskan yang PX ini kalau saya beringkaskan okay, 0 PF, right? Kalau kita kira VPX ini, sorry, soalan ni dia nak cari, oh sorry, VB, sorry, sini VB, sini VB X, sini VB Y. Okay, saya tertinggal tadi tu Jadi kat sini, kita ada kat sini saya padam balik sini supaya boleh nampak Okay. Sekarang ni kita nak cari V kat sini kan berapa. So kalau kita pakai segitiga kat sini, kalau kita guna Pythagoras, sini sini katalah VBX, sini ke bawah ni adalah VBY. So kalau saya besarkan lagi dia punya ni gambar rajah ni, maksudnya sini VBX, sini kita ada ni VBY. So yang kita nak cari ni adalah inilah V ni, yang VB ni, okay, VB. So kita boleh guna Pythagoras lah. So maksudnya sini VB is equal to VBX square plus VBY square. Itu maksud dia lah. Okay. Untuk mencari VBX, untuk mencari VBY, kita dah ada dua persamaan. Kita boleh gunakan keadaan gantian ataupun bergantunglah kepada kamu untuk mencari apa. Boleh ganti nilai Mass A dia bagi sini berapa? Mass A kalau kita tengok moving dia bagi mass tak? Okay. A 20, B 25, apa lagi? Lepas tu UA kita ada 25, UB kita ada 15, tapi UB tu ke arah kiri, so mesti letak negatif. Last sekali, MA kamu gantikan sini adalah apa tadi? 20, this is MB 25. So last kamu boleh cari dia punya VBX. Sama juga kat sini, MA adalah 20. Okay, gantikan 10 sin 35. Apa ni? MB, okay, berapa tadi? 25. Okay, kita boleh cari VBY. Masukkan VBX kat sini. Masukkan VBY kat sini. So, kita boleh mencari VB. Right? Itu dia punya cara dia. So, kamu kira lah. This is, dia bagi jawapan saya rasa patutnya dapat lah. Okay? Saya tunjuk dia punya kaedah ni. So, next dia nak cari berapakah dia punya direction. So, macam biasa juga kalau kita pakai resolving vector ya, untuk cari direction tu kita dapatkan saja direction. Sebenarnya direction ni dia punya angle sini ya, theta kat sini ataupun theta ni di sini. Bola ni ya, BB tu. So kita pakai theta is a inverse tangent, inverse tangent V B Y divided by V B X. Tapi kita dah kira sini VBX, VBY. Maksudnya kita just masuk sajalah nilai ni berapa. So nilai ni berapa. So kita akan dapat nilai kita. Cuma kat sini VBY tu dia ke bawah ke bawah. So meaning we have a negative. That's why kamu akan dapat sini. Nanti kamu kira nanti So kamu akan dapat dia theta is a 21.6 degree tapi dia ada negatif. That's why tangent negatif ni berada pada sekuan yang inilah theta kat sini. Okay kelas. Jadi kita sudah sampai ke habislah. Okay, soalan kita tutorial 3 ya. Jadi apa yang kita bincang tu mungkin saya bagi secara umum saja. Mungkin kalau ada yang tanya ni bukan positif. Mana satu saya tak, because saya telefon saya tak dapat buka untuk mana ni. Saya tak boleh nampak mesej ya. Terus kena buka kat sini baru nampak. Asrul Nizam ni dia tanya bukan positif ke apa maksud dia tu? Yang mana satu VB dalam equation 1 tak ada dalam si theta kah? Wow. Oh, VB. Oh, saya dah faham. Okay, VB. Oh, kat sini. Sorry. Okay, so maksudnya VB. Okay, ya bagus soalan itu. Siapa tadi tanya tu? Okay, maksudnya dekat sini. Ya, memang tadi kalau kita nak resolve kat sini, memang ada theta kan? Tapi kalau kita resolve kat sini tadi, M B VB this is VBX VBX ataupun VBY lah. Memang dia ada, kalau kita tengok ada cos theta contohnya kan, ada cos theta. Tapi ataupun dengan kata mudah, VBX ini yang kat sini kita sudah kira VBX. Kita nak cari sini VBX. Mana VBX ni sudah termasuk dengan dia punya cos theta teruslah. Terus kita dapat because VBX kan. Sama juga dengan sini VBY. Ya, ada MB VBY sin theta. Tapi kita anggap VBY ni, VBY kat sini tu sudah termasuk kat sini lah. Because kita nak cari VBY saja, itu maksud dia. Saya faham apa kamu masukkan itu. Okay, kita ada B kat sini. Okay, VB. Ya. Kalau kamu tengok sini pun theta pun dia tak bagi kan. Dia tak bagi kat sini kan. Tapi bila kita resolve kepada katalah sini VBX, automatic VBX ni dia kita anggap dia dah terkira dah kat sini, iaitu sama juga dengan VBX cos theta. Jadi kita ambil VBX sajalah dalam persamaan tadi. Itu mengapa sebenarnya dia VBX itu dah termasuk dengan cos theta tu kita ambil, kerana kita nak cari VBX ni saja. Kita nak cari VBY ni saja. Itu yang kita tak masukkan tu. Dia sudah kira, patutnya sudah kira sekali. Itu maksud dia lah. Right? Sorry. Okay, so jadi saya rasa untuk malam ni Jelas saya secara sepintas dulu kan. Nanti kalau tak faham boleh tengok balik dia punya video ni. Okey, kalau tidak jelas ataupun tidak dapat juga, nanti kelas minggu depan saya rasa kita terutama yang soalan nombor 8 dengan nombor 9 tu ada kelas tutorial lagi yang saya belum bincang. Saya akan bincang yang 8 dengan 9, dan mungkin pada minggu depan hari Isnin tu kan, ataupun hari yang first class tutorial tu saya nak belajar bentang macam mana nak selesaikan soalan nombor 9 dan nombor 10, iaitu melibatkan two dimension. Okey kelas, jadi untuk malam ini itu saja. Kita jumpa lagi pada sesi yang akan datang. Sekian, terima kasih. Assalamualaikum dan salam sejahtera. Selamat malam. Bye-bye.